Hello students, this recording is provided for Engineering Economy on Friday the 12th of January 2018. As you already know, we're not having class today because I'm going to be out of town, and so today's recorded lecture comes from a previous semester. All of the material is the same, although there may be some references to different times and places that may not exactly match up. Just to eliminate any potential for confusion, these announcements predominate, and these are the ones that you should follow. So let's take a look at those. The homework assignment number 2 is due a week from today. It's going to be submitted to MU Online by Friday, January 19th, before 12 p.m., which is noon. And just as a reminder of what I've mentioned in class already, you should submit that assignment as a PDF file. Now, those are mostly hand calculations that you'll be doing on paper, and so the easiest way to submit a PDF file is to use the Cam Scanner app. And when you do that, please make sure that the settings are on black and white. That way the image is the most clear and sharp. Of course, you could also use a flatbed scanner or whatever means you prefer to generate a PDF, but the point is it should be submitted on MU Online before noon on Friday the 19th. And if you have any questions on that homework assignment, you can feel free to stop by during my office hours or ask me during class before it's due. Now, today's lecture is going to be focusing on the time value of money, and specifically some of the way that we abbreviate the types of problems that you're likely to see and how we can translate those problems into some visual representations known as cash flow diagrams. So through today's lecture, it's going to be, as I mentioned already, a previous recording of a different semester, but there is an accompanying in-class exercise, and I've already shared with you the PDF file for today's in-class exercise. I would encourage you to take the time and solve those as though you are actually in a classroom environment. Don't just look at the solution, but take the time yourself to try and figure out how to solve those problems and do the calculations and work through the learning experience so that you're prepared for the homework assignment when it comes.
One of your homework assignments asks you to identify some symbols by breaking down a problem statement. And these are the kinds of symbols that it's asking you to assign by reading into the text and finding out, breaking the problem down into its variables. And so in problems like that, say for instance we have this statement. You borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? And so what you should do is, in this problem statement, try and find out what is the I, what is the N, P, and F. So the easiest one probably is the interest rate because it's got the little percentage after it. And so what you could say is I equals 6%. N isn't always the number of years. Sometimes, depending on the terms of the loan or how often interest is compounding, your interest periods may be months, it could be quarters. Stocks, for example, often pay their dividends on a quarterly basis. In this case, though, the period is a year, so N would be 5 years in this problem statement. So what about P and F? Well, if you read the problem statement, it doesn't actually say that you borrow $10,000 now, in the present. It doesn't say it directly, but it's kind of implied. You know, when you borrow money, that's when cash flow diagrams begin. So you'll get more experience with this, and you won't need it to say explicitly you borrowed $10,000 at year 0. But you know, this is a transaction that all time references begin with the borrowing of that $10,000. So what we say is that P is $10,000, and how much must be repaid? Well, it's talking about at the end of 5 years how much must be repaid. And so F would be equal to question mark. That's the unknown for this problem. So this is how we can summarize it. P, I, N, and F. All right. Any questions about that technique of breaking down a problem statement and assigning the variables? All right, we're going to change gears just briefly. We got a taste of different types of accounts in class last time when you were online trying to find interest rates for different types of accounts. But it's important when we talk about taking out loans or interest rates that we keep in mind the types of accounts that are available to not only individuals but also businesses, because some of you may work for engineering firms or private companies that these financial matters are kind of important. So a checking account usually is something that you have lots of transactions against. The money may not stay in a checking account very long. There's high turnover, and it's uncommon for checking accounts to receive much appreciable interest. A savings account, on the other hand, the money goes in and out of a savings account generally slower. That's where you're putting it in to try and gradually over time accumulate interest. One difference between the savings account and the money market account that you were looking up, the EverBank money market account from last time, is that in the case of a money market account you can write checks, but savings accounts typically don't allow check writing. And so a money market account is kind of like a hybrid between a checking and a savings, in that you have easier access to your money, but it also has higher interest rates. And there also is a federal regulation that money market accounts can only have 6 transactions per month. And so that's kind of in between the two. A certificate of deposit, or a CD, is kind of a contract between you and a bank where if you're putting money into a CD, you agree that you're going to leave it in for a fixed amount of time. And in exchange, banks will typically pay a higher interest rate on a CD than they would on a money market or savings account. And the reason why they're willing to offer a higher interest rate is because it gives them more security on how long they can loan the money out. So a savings or money market account, they have to give that back to you anytime with no advance notice. And so it makes it harder for them, for example, to take your money for a savings account and put it into a 30-year mortgage for someone else who's buying a house. Because they have to have enough money on hand that any of their customers liquidate their savings or money market account, they have the money at the ready. But a certificate of deposit kind of gives the bank more stability of funds, and so as a result they're willing to pay slightly higher interest rates. Although these days even CDs don't pay enough to be worth your while. I mean, if you look at the rates of any of these types of accounts relative to inflation, you basically lose money if you're putting it into the bank, because the price of goods is increasing faster than the value of your money when you put it into the bank. It's kind of a bad environment. Any questions about these different types of accounts? All right, so how do you get at your money? Oftentimes you'll carry plastic around in your wallet, and even though the plastic may look the same, it has different implications. A debit card is, when you're making a payment with it, it comes directly from your checking account. So that when you pay with a debit card, you're not incurring a debt that has to have interest paid on it. But you can only spend as much as you've got. Occasionally banks will have overdraft protection, which is just sort of like a small automatic loan that pops up if you accidentally overspend on your checking account. But more commonly, if you're going to buy something on credit, you'd use a credit card, and those are unsecured, meaning that when you spend that money, it's typically not on things that the bank can come back and repossess, in the same way that they could take back your car if you don't pay your bills, or repossess your house if you don't pay your loan. If you think about a credit card, the types of things you're buying it with it, you're buying coffee, sandwiches, airline tickets, and the bank can't repossess your sandwich. So that's why partly the interest rates are higher on credit cards than they are on other types of secured loans. So a mortgage or a home equity loan, these are both secured by ownership of your house. And so that if you don't pay your bills, the bank has something that they can resell to try and recoup the value of that loan that you took out from them. And that's part of the explanation why mortgage loans have so much lower interest rate than credit cards. The difference between a mortgage loan and home equity, though, is that the mortgage loan is used for the original purchase of the house. It's the loan that you'd use to get into the house in the first place. And then as you're paying off the mortgage loan, let's say the house is worth $200,000 and you only owe $150,000 to the bank after you've made some payments through the years. So what that means is that you have $50,000 in equity, that of that $200,000 the bank owns $150,000 and you own $50,000. So you can take that value that you own and get a loan against it. And that's what a home equity loan is. It's when a bank will loan you against the portion of the house that you are the owner of, and then you can use those funds to do something like remodel your bathroom or put in a new driveway, or sometimes it's not even related to household expenses at all. Some people use home equity loans to pay for education and cars and so on. But it's secured by the house, so that if you don't pay your home equity loan, then they can, in theory, repossess your house. Any questions about these kinds of accounts? All right. So back to this idea of assigning terminology. Oftentimes, different textbooks have different abbreviations, and so some of you may end up taking the Fundamentals of Engineering exam or other kinds of licensing tests that have, as a small subset of the questions you're taking, questions related to engineering economy. So you may have a test that talks about PV, which means present value, and you're accustomed to hearing about present worth. Well, don't let a change in terminology throw you off. They all mean essentially the same thing, and through the course, I'll use some of these interchangeably. I won't typically talk about discounted cash flow, but we will sometimes phrase the amount of money today. We'll sometimes call that the present value or the present worth. Sometimes we'll convert future amounts into its present equivalent. And so, for instance, we'll say $500 10 years from now is worth how much in today's terms. And so this word discount is talking about the process of moving money from the future into the present so that you know how much it is today. And it's called discounting because money is worth less in the future than it is now. And so that $500 in year 10 is going to be worth less than $500 in today's terms. And so we would need to discount that quantity to find out its worth today. It's very uncommon. There's something called deflation. And deflation means that instead of prices going up, which is the typical thing, prices are going down. And deflationary periods only happen when an economy is sort of in trouble. Like when people are afraid to spend money, then retailers have to start lowering prices of things if there's not very much demand. So let's say, for instance, if the nation is starting to go into a recession, then Best Buy and Amazon, everybody's lowering their prices to try and entice people to buy. But then it's kind of a chain reaction, because if you know that prices are going down, then you say, well, maybe I'll wait till next month, because you don't want to spend $100 now on something if you think it's going to be $95 after another month. And so deflation actually goes in sort of a tailspin where nobody wants to buy because everyone's convinced it's going to continue getting cheaper. So that would be a case where it's the opposite of usual. Usual is inflation, but sometimes it does happen the other way around. So present worth has a couple of different synonyms. So does future worth. Sometimes we call that future value instead of future worth. Now, annual worth is what we're going to call when there is a series of identical payments over time. If you're paying the same amount or if you're receiving the same amount, period after period, that's called an annual series or an annual worth. It's where you convert, say, the amount of money you're receiving from the bank today into how much you have to pay them every year for 30 years, or every month during a 30-year period. So we can convert back and forth between these different perspectives actually very easily. We're going to do it 3 different ways this semester. You'll have equations that you can do these conversions with, and there are also tables that they've already done the math and you just multiply an amount by a factor. So that's called the factor method. And then also there will be the days where we're working in Excel and there are automatic functions built into Excel that do the conversions for us very easily. So you'll learn all three of the ways to convert between these different time frames of money. So here's another look at these abbreviations. I, we already talked about, interest rate per period. N is the number of periods. Sometimes periods are years or months. F and P. So A is sometimes another abbreviation we use for an annual series if it's a recurring, ongoing periodic amount. All right, so here's the bulk of what we're going to be working with today, is setting up cash flow diagrams. You got a first opportunity to draw your own cash flow diagram last time without ever having seen an example of what they're supposed to look like. That'll change today. The standard, like sort of our convention, is that when cash comes in from the perspective of whoever we're doing for a cash flow diagram, let's say it's your perspective. When you receive money, then that means that the line should be up, or that we have a plus sign for that amount. So that can include revenue if you're operating a business, receipts if you're selling things, income, if you have a salary, or customers who are paying you. And here's an interesting thing, that if you have expenses and you find some way to trim those expenses, like cutting your power bill or negotiating a lower rent rate with your landlord, savings are also considered as an inflow. So keep that in the back of your mind. So all of those things you can consider as money coming to you. We have a plus sign and the arrow goes up when we're doing the cash flow diagram for cash inflow. Outflows are the other way around. So that's any time you're spending money. The money is coming out of your wallet. So disbursements, costs, expenses, taxes, that's a minus sign. You can think of money as kind of like a tank. Your checking account is like a tank, and money comes into the tank, money goes out of the tank, and hopefully, in the case of your checking or savings account, you want the tank to be filling, or at least steady, because when the tank is draining, that means you're spending more money than you're receiving, and that's not sustainable over the long term. The difference between the two, the difference between the cash inflows and outflows, is the net cash flow. Sometimes you'll have both expenses and revenues in the same year. And so you'll need to account for the difference between the two of the inflows and the outflows and find the net amount for each year. And this is especially important for some of the Excel calculations that we do, because we'll have some methods that if you don't use the net cash flow, the answer is slightly wrong. You'll see what that means when we get into the Excel stuff, but just from a definition standpoint, net cash flow is the difference between inflows and outflows for a given year. Okay, the end of period assumption is a little bit of a simplification that we use to make it easier to calculate all these kinds of problems. And what it is, it assumes, for instance, that you work during a year and then you receive all of the inflow, all of the revenue to you at the end of that year period. Now, in reality, you may get paid every month, or you may get paid every week. And you can do a cash flow diagram on a week-by-week basis, but then you end up with really a lot of lines and a very lengthy cash flow diagram. And so when you break time up into periods, we're assuming that your expenses and your revenues are all received or paid out at the end of a time period. Now, most of the time, these amounts are estimated as a point estimate. It's hard to predict exactly what's going to happen in the future. And that's one of the things you always need to remember about these cash flow diagrams, is that often the amounts are just estimates of revenue or estimates of expenses, and you can't count on them being exact. So if you assume that after you graduate you're going to have an income of $150,000 per month, boy, that would be really amazing. Maybe this is a business's income rather than an individual's income, but that point estimate may or may not be accurate. And so all of the project planning you do based on these estimates has to be contingent. You have to put in some analysis of what's the likely range. And that's what a range estimate is trying to identify the minimum or maximum amount that may bound a particular cash flow. So let's say that you're going to be purchasing equipment some years in the future and you don't know exactly how much that equipment will cost, but you estimate it would be between 2.5 and 3.2 million. So that's just an illustration of the difference between a point estimate and a range estimate. Most of the time we'll be using point estimates. But if you're doing cost analysis and engineering economy for a real business, you do a lot of different point estimates so that you can get a handle on what's the range of possible outcomes. Just to be on the safe side, you want to be aware of what happens if your business isn't doing as well as what you hope. Okay, so drawing a cash flow diagram. What you do is begin at year 0, you have a horizontal line and then put these little tick marks in them, evenly spaced. Now, this is a situation where I'm not going to deduct points if you're 1 millimeter off from even spacing. I, more than anyone, know that it's sometimes hard to do these drawings really neatly. But it's much easier if you're using Excel or if you've got some of the engineering paper that has the squares on the back of it. That makes it a little bit simpler. But each one of these marks can identify a time period. It may be a month, it may be a quarter or a year, and you just have it continue through the number of years that are described in the problem statement, assuming the end of period cash flows. And that's what we were talking about a moment ago, where when you have revenue or expenses, you would put them at the end of a year. So this 1 refers to the end of the first year. So year 0 is the present. Any money that you receive for working during the first year would be a cash inflow at line 1. Even though you did the work over a 1-year period, you receive it at 1. The length of the lines is approximately supposed to represent the amount of a cash flow. And like we were talking about before, inflows are pointing up and outflows are pointing down. It's also customary to, in addition to writing the amount next to the line so that you can know how much the inflow or outflow is, it's also customary to write these variables. P would be an amount at the present. F would be some amount in the future. If you have a lot of ongoing payments that's the same, then that would be an A, an annual series. And you'll get in the habit of drawing those labels just because it makes it easier to translate the picture into the calculations that you'll need to do. Any questions about this cash flow diagram standard convention? All right, so I have an in-class exercise for us to work on today. First, you'll be classifying a variety of different categories of a university's inflows and outflows. You'll be putting it into which it's supposed to be for problem 1. In problem 2, you're translating a cash flow diagram into a table. And then there's also some problems on the back side as well where I ask you to draw cash flow diagrams. So I'm going to be circulating around with the solution as you're working on this. I can answer any questions you've got, and of course I encourage you to work with partners or in groups on these in-class exercise. It definitely does not need to be quiet in here as we work through these. There you go.
At this time, pause the recording and work through problems 1 and 2 of the in-class exercise handout. When you've finished your best effort for problems 1 and 2, then resume the recording if you want to take a look at the instructor's solution.
Okay, most people are finishing up with the front side of the paper, so let's pause for a moment and just make sure we're on the same page with everything. So if you break down these different types of inflows and outflows, some of them are a little bit subjective and may be in one column or another, and I think I had a few more categories on this paper when I did it in a previous semester. But parking fees, for example, get paid to the university. That's not them paying you to park in the parking lots, as I'm sure you already know. Tuition is an inflow to the university. Application fees is cash coming to them. If you think about the Pizza Hut or the Starbucks on campus, those are the retail outlets, and they have to pay rent to the university, so presumably they're getting some income from that. Savings, remember, if you are able to somehow reduce your expenses, that's considered as an inflow. So savings from cooling system improvements, patent commercialization is when they have, like someone, oh, you didn't have that on yours, did you? No. All right, well, we don't need to talk about it then. Any questions on this first one of inflows versus outflows? All right. What I really want to do is show you a couple of things on this cash flow diagram. So all of these amounts in years 1 through 5, those lines are the same length, and then there is an A above it. The A label should give you a clue that there is a recurring amount that's the same. And so even if they were slightly different, because like I have a sloppy hand or something, the clue is if they look about the same height and there's an A, then that's an annual series where the amount is recurring every year. So that's one thing to know about that. The P with a question mark, this picture is really a problem statement. And what this picture is telling you, the reason why that line is so wide is that's to identify the unknown. What it's saying is all this stuff's going to happen in the future. In the future, you're going to get money. You'll have a couple of years where you have an expense. What this problem statement is, from the picture, is saying, find out the present value of all of these future cash flows. And so it's saying, what is the present amount of if you discount all those future expenses and revenues to year 0? So we said it's from the picture considering as 0 inflow and an unknown outflow. This net cash flow column is only for a row-by-row basis. It's not cumulative. Later on, we will do some spreadsheets where you find an accumulative amount, but this one is just for each row in question, the net cash flow for year 5, for year 6, and so on. Okay, so any questions about the first two problems before you continue with the back side of the paper? All right.
At this time, you should pause the recording and work on problems 3 through 6 of the in-class exercise, and then resume the recording when you're finished with that and want to compare your work to the instructor's solution.
So 3 and 4 are really just mirror images of one another because of the difference in perspective. As I circulated around, I think everybody picked up on that concept that if it's going to be an inflow from your perspective, then that means it's an outflow from the bank's perspective. If you're getting the money, they're giving it up. So that's why the line is up for the problem 3 and down for problem 4. And then the clue that there's only a one-time payment is it says, is it on this side? I think the sound is turned up all the way over here. Paranormal activity again. There we go. All right. I don't think it'll happen again. All right, so it's a one-time payment, this $30,000. In 3 years, you'll pay. All right, so here's the last one. The cash flow diagram for number 5, there are actually 2 right answers. One approach is to say that the annual series continues through 6 years. And so it's going to be that same arrow height for years 1 through 6. And then in year 6, there's also a separate future amount of $50,000 on top of the annual series that was already there. Or you can also have the annual series only going years 1 through 5, and then a one-time F of 135,000. Both of those, if you were going to move the money back and forth, both of those are acceptable, and you'll get the same amounts if you're converting from future amounts to present values and so on. So that's what I'm saying here in this typed in text, that the A, as I've drawn it, is in years 1 through 6. Does that make sense? All right. Number 6 is tricky. This is the kind of problem that, sadistic professors love to put onto their exams, because it's not till the very end when it says, draw the cash flow diagram from the bank perspective. It's really easy to sneak that in there, do it from this opposite perspective than you might actually been ordinarily thinking about, because it says you saved 10,000, and so you're thinking, okay, this is from my perspective, but it's not till the end that the switcheroo occurs. So be careful. I won't intentionally be tricky like that. When I ask for an alternate perspective, I'm not trying to get you, but read the entire problem statement and it won't be an issue. So since it's from the bank's perspective, what that means is you walk in every year and give them 10,000, and then at the end of the 7th year. So the end of the 7th year, that's a little bit tricky too, because you may be thinking, does the end of the 7th year mean at line 8? So eventually it'll come naturally, but here is the end of the first year. The first year goes from 0 till 1. So that first year is a year in length, and it ends at the number 1. So that's how you find out the end of the first year, and so on until you get to the end of the 7th year